Hey guys, the objectives of this video are to look at an example on flow out of a tank using the Bernoulli equation. Here's our example. For the below tank, the cross-sectional area A1 is far greater than A2. Find the discharge velocity. So this is our tank. The area A1, which is the area of the surface of the fluid, is far greater than the cross-sectional area A2 of the bit of pipe leading out of the tank. And what this means is that since A1 is much larger than A2, we can assume the height h changes an insignificant amount because only a small portion of the fluid is let out at a time. So first what we need to do is establish the datum. We'll put that at the top for simplicity's sake. So here's our datum. You can put it at the bottom if you like. It doesn't make a difference because we're taking a difference of heights. It will all be the same, but we need a reference line to which we make our calculations. So that will be the top of the fluid. Next, we need to select our streamline. Remember, this needs to have 2 points which have the least unknowns so that we can solve the Bernoulli equation for one unknown, which in this case is the discharge velocity. So let's look at if we choose the streamline starting at the top of the tank and exiting out the tap, looking like what we saw in the previous video, be something like this. So that's our first point at the top, our second point there, and that's our Bernoulli equation for those 2 points. Point 1 and point 2, we need to find pressure, velocity, and height for each point. Point 1 is exposed to the atmosphere, so the pressure here will be 0. Point 1, redraw that in. Point 2, because that's exposed to the atmosphere, P will be 0. Also, our velocity will be 0 because that moves at such a slow rate. The height changes so insignificantly that we can consider V to be 0. And also our Z is going to be 0 because we chose our datum as the top of the fluid. So all of that will be 0. For our point 2, our pressure will also be 0. That's exposed to the atmosphere as it exits the tank. Our velocity is unknown. That's in fact what we're trying to find, the discharge velocity. And the height will be negative h. So 0, we're going to call that v, and that will be negative h. So we found all the variables except one, which is the one we need to find. And we'll put all that into the equation and rearrange to get the discharge velocity. So putting all that, subbing that into the Bernoulli equation, we get 0 plus 0 plus 0 equals 0 plus v squared on 2g minus h. And if we rearrange that, we'll get v is the square root of 2